Greetings, everyone. My name is Tim Burrows, and I'm pleased to welcome you all to episode 24 of EV Society's Canada Talks Electric Cars webinar. We see increasing numbers of electric vehicles being delivered with a promising new capability referred to as bi-directional charging, or perhaps more accurately, bi-directional power transfer. Simply put, the technology will give us the ability to use energy stored in our car's battery for other things besides just operating the car. Imagine thousands of plugged-in EVs being able to support the electricity grid by sending back stored power during periods of high demand. The jargon for this is V2G, vehicle to grid. Or imagine using your car's battery to power your home for a couple of days during a power outage. In this case, it's V2H, or vehicle to home. Bi-directional charging could make it possible to charge another electric vehicle that runs out of juice roadside using your car's battery to help them get on their way. How about the ability for a construction worker to run power tools and equipment at the work site right from their vehicle? Actually, your battery could power nearly any electric appliance, just about anywhere. You might just want to pack your toaster, coffee maker, and even a waffle iron on that future camping trip. Before we get going into this, now that you're all experts and you see some of the capabilities that this will provide, we're going to launch a quick poll just to see how people will use this sort of technology. There we go. Hopefully you can see that. So your choices are, you think it's going to be most useful to help somebody stranded, to use it as backup power during a power outage, to use it to send energy perhaps back to the grid, maybe for payment of some sort, or to run power tools or other appliances when you're out in the wild. But enough, we got almost 75% of the room have submitted their thoughts on this. So I'm going to end that, and I'm going to share the results with everybody. And you can see that it's interesting. The number one capability that people seem to think will be useful to them is charging another vehicle roadside. So I'll just wonder how many of you have run out of electricity in your EV. Backup power at the home is number two. The third choice, energy back to the grid for some sort of compensation. And finally, running that waffle iron at the campground. So I think that what it shows is there's still a lot of interest in all of these capabilities, but it's just interesting to see what people think will be most useful. So thank you for participating in that. So before I introduce our guest, Ivano, just a few housekeeping issues. Remember to submit any questions you have for Ivano using the Q&A feature on the toolbar. And again, we have Jason back with us to monitor your questions, and he'll introduce your questions at the right time. Remember to give them a thumbs up if you see a question there that you want to hear answered, so we make sure we'll get to it before we run out of time. And as always, we're going to end this webinar sharp at 8:30. So tonight, we are fortunate indeed to be joined by Ivano Labricciosa, President and CEO of Oshawa Power and Utilities Corporation. Ivano is speaking today about how electric utilities in Canada will need to prepare for the arrival of bi-directional charging. Ivano's experience spans close to 40 years, both in Canada and internationally. With a background in engineering, business development, and strategic planning, international expertise in alternative and renewable energy, Ivano brings innovative leadership not only to Oshawa Power, but to Ontario's entire energy sector. Ivano holds a Bachelor of Engineering Science degree from Western University, a Master's of Engineering degree from the University of Toronto, and a Master of Business Administration from Queen's. He's a graduate of the Directors College at McMaster University DeGroote School of Business. Hey, Ivano, welcome to Canada Talks Electric Cars.
Thank you, Tim. I'm proud to be here and glad to be speaking about my favorite topic, electric vehicles and the grid.
Wonderful, wonderful. Well, I'm going to get out of your way and let you have at it.
Excellent. Again, thanks to the EV Society for having me on. Let me see if I can just clear some of these things on my screen, and you should be able to see my screen. And I just want to sort of preamble this. I'm going to try to get through it so that we leave good timing at the end for questions and answers, because that's usually my favorite part of the whole presentation, not the one-way dump of the slideshow. I'm going to try to get as much through that to sort of whet your appetite, and then look forward to the questions that you have coming down the pipe at the end. I want to be a little controversial. I've heard a lot of people talking about EVs and grid readiness, and I'm going to tell you, I'm going to steal the thunder a little bit and say I'm a little bit different in the thinking. Most people are talking about the billions of dollars that have to be invested in the grid, and I hear a lot of CEOs talk about that, and I often wonder, are they really speaking from a conservative point of view or from a real technical point of view, and understanding what the grid already has in it? There's a lot of capacity in the grid, and I'm going to speak to that and really pick the side that says, um, we don't necessarily have to put the billion dollars in. There's a lot more squeeze left in the grid that we could use, but we will have to do investments, and we have to do investments in the right area. So I kind of preambling the whole presentation that way, but let's get at it and talk about how we could do that. So it wouldn't be a presentation if I didn't talk about the great city of Oshawa that I represent, and we're so proud of what we're doing here in our diverse economy and community. Historically known as GM, the Oshawa is known as the city that motivates Canada in terms of our history. But today, I'm proud to say we've got Ontario Tech, Trent Universities, and Durham College. So we're like an institutional town with 25,000 students. We've got the fifth fastest growth in Canada. So we're an emerging population that's growing at leaps and bounds. And on the screen there, as you see, a whole bunch of uh, data points or informatics about Oshawa. So we're quite a growing and diverse community. And certainly, when I talk about Oshawa Power, I'm proud to represent three parts of our company that all fit together, and it's great under this presentation. I'm going to remind people the networks company, the old LDC, is 130 years old and has a legacy and a history of connecting everything that needs power. So, electric vehicles are no different than the turn of the century appliances and everything else we've done historically. So, I am kind of taking the position we're ready, we're able to connect, we have a history and a legacy of connecting everything that needs energy, and electric vehicles are no different, but we are working our way through getting ready for that too. The other companies I represent are Enerforge, which is really a clean energy services company. We own windmills and solar panels and do consulting work and operate the largest public housing complex at Toronto Community Housing in Canada in terms of operating a district energy system. So really proud about our work there. And then last but not least, Durham Broadband, our telecom company, which is a full internet service provider with one of the largest fiber installed bases in Durham region. So really proud of those three companies. And there's a strategic fit with all these three companies. And we'll talk about the connectedness and how that fits in as we get through the presentation. So I usually start, I was telling Tim, I went back in time and pulled out a presentation from 2010 where basically it fits today quite nicely. Historically, we've been talking about EVs and its impact on the grid for many years. And one of the lines I caught in there was this Ontario government line saying that 1 in 20 cars by 2020, which represents about 5% of vehicles on the road, is what we were predicting back then. Fast forward to today, we're at 0.5%. There's about 70,000 electric vehicles in Ontario with a base of 12 million vehicles. So we were off by a factor of 10, but that doesn't mean it's not coming. I'm just saying we were predicting and measuring and looking out and getting ready for this. And good news is we did put a lot of effort in this. I mean, I'm showing you some slides where same things we said then as we're saying now. EV adoption is a vertical curve. It's growing, and we'll see that in a second. We wanted to get to cleaner transport. We saw that advantage 10 years ago, and lo and behold, governments are really pushing the carbon footprint and the clean green way of moving us around, and that still applies to today. We talked about the EV and the grid being the service stations of the future. And back then we were contemplating utility control. And really it was around control the charging and facilitate what we called grid management and getting ready for its impact. And then last but not least, we envisioned ourselves having utility management of the customer bill and what that would look like and how we would bill customers for energy and the like, somewhat what we're doing today, but in a different way. We had ideas of how we'd put it all on the bill. I wouldn't be complete if I didn't talk about some work we did in IEEE way back then. And so we did some early research work, and it's published here, but with some initial findings that still apply to today. But that was kind of looking back in time. So I want to walk you through two kind of perspectives, and I want to do the macro perspective because essentially I want to kind of remind us why Ontario is a huge advantage. We have a very clean grid. We did a lot of work in the 2000s around cleaning up electricity supply, and you can see we're pretty much a very low, ultra low carbon emitter. But when we look at how we're using energy, which includes gas and electricity, 37% is industrial. On second major use is in transport, which is pretty much entirely refined petroleum products. So when you look at the opportunity, we have a clean way of generating energy, but our heaviest opportunity is in petroleum in terms of reducing the next carbon footprint. And so when you look at that, the combination of the two pretty much focuses on today, you look at transport as being our biggest emitter, basically petroleum fueled, our largest emitter, greatest opportunity to go green. So if we're going to go to climate change and hit our targets, that's where the effort is. So that's kind of the the thinking and how it sort of fits together strategically today. When you actually look at the adoption curves, I'm kind of showing the latest and the greatest. 2021, the latest information shows the adoption curves are climbing. We're almost seeing this vertical adoption curve. We're at the knee of the curve, possibly, where the amount of new EV sales is climbing, and the latest data out of 2021 shows 65,000 brand new EVs in Canada. So a lot of data that shows climbing, higher interest globally, and you see North America's piece. China, big growth there. Again, biggest opportunity with emerging economy and a cleaner need in that society. And so it is coming at a global scale, and it is on the adoption curves. And you hear it in North America, 250 EV models coming out in the next number of years as higher choices. So the development curves and the adoption curves are getting steeper and steeper. So it is coming, even though I've said 10 years ago we were saying that. When I look at what we were talking at a macro level, people were looking at trying to get a microgrid component. So power our EVs through renewable energy. Wind does not work. I've pulled this off the ISO page. When you look at the intermittency of wind, trying to get a direct connection of a wind to charge a car battery, it just doesn't work. The variability isn't there. It doesn't call for a reliable source. When I look at how EVs are used, I mean, the daytime is when the highest use for EVs, whether it's public transit or whether it's personal use or whether it's a little bit more flatline in terms of trucking use. Vehicle use is pretty much a daytime thing. So it's really poor for solar when you need the vehicle, but solar is most available during the day. So trying to connect renewables and EVs is not necessarily a good idea or a good way to make it fit. But what we will say is the biggest opportunity in terms of grid management is the supply side shows charging at night when you're not using your equipment is definitely the way to go. So you've heard the story, peak shaving, valley filling, very good way to do to do and manage EV at the macro level. So one other thing, I'll give you the latest and the greatest. The ISO, the Ontario IESO publishes their macro grid characteristics in terms of load curves. And the first curve I'm pointing to with the laser, the old light green curve is kind of pre-COVID. And so COVID impact, because that is something we're gonna have to live with, we have to do it for the last 2 years, has basically blunted the curve in terms of peak and also sort of changed the shape and flattened it. It's important because the latest, I went yesterday to get the latest curve. You can see it usually would be a double hump characteristic, and it's a lot more flatline. So this notion that you can peak shave and valley fill at the macro level is kind of, we're losing that ability to move and charge. We can still have some valley fill in the after hours of the time of the day, but not so much during the day. So we're kind of losing that flexibility at the macro level when you start looking at the load curves and how EVs can fit into that world. The one that I'm most surprised is, and I put the slide in here, is projecting out. We know we have in Ontario, we have a supply demand concern. We're eating more and more into our margin as fewer resources are coming to the supply side. We cannot build them fast enough without going to dirtier energy sources. So we are exploring the small, medium nuclear reactor technologies, but that's not coming for some time. So we're going to have to make use of what we have existing in a better way. But when I forecast out, the fastest growing trend is in the transport sector, whether it's agricultural transport and use, like for farming, or whether it's personal use in transport. It's the largest growing segment when I look at the load forecast for demand for electricity. And when you look at this chart, it's actually net energy. So what I like to point out is they do see in the forecast a netting effect of EVs, using it as bi-directional, a source and a load. It's not one-way planning. So the point I want to make here is our planners are moving with the times, dropping the old ways of which we used to plan, which is all one directional load and maximizing, like assuming the worst conditions and maximum peak. And they're starting to think of planning in a different way, given where EVs and the transport sector is going. So the good news is I'm really confident in our planners. I've been here a long time, so I've been around for 40 years. So I'm used to the old way of planning, but I'm actually encouraged that our planners, especially at the ISO, are thinking about these technologies and looking at them in their proper way and adjusting their planning horizons and their planning models. So fastest growing is transport. Biggest opportunity is transport. When I look at transport and how we forecast out and plan, we take it as a netting effect. So there's some incorporation of bi-direction inside that forecast. So very quickly, version 1 of V2G is basically simple charging or smart charging. There's some elements in the smart that talks about controllability. And so here we go. Our strategy at Oshawa Power. It's electricity flow, the networks. It's communication connectivity when it comes to communicating between the vehicle and the grid when it talks to Durham broadband. And it's definitely data and the use of data when it comes to analytics with Enerforge and understanding how electrons flow both ways into the grid and using energy in a smarter way. This version 1, the best you get is what I call controlled charging. It's still one directional, not two, and essentially it's what I would call throttling the use of the electron going in the one direction. So it's able to do it in a way that controls it to get the outcomes that you're looking for. When you look at version 2 in vehicle to grid, it's integrated charging. It's bi-directional. And so what I point out is there's new components that are necessary, and this is where the emerging technologies are. You need this bi-directional AC/DC power inverter. And so a lot of arguments in the manufacturing world. When you look at what we're dealing with here, you have many players. You have to collaborate. You have to have standards. You have to deal with the technology aspects, but use them to your advantage. So the players have to work together. So in a bi-directional EV charging world, there's extra technology that gets deployed and it's necessary. Manufacturing side looks at that as a cost. So it's a little bit of a detractor, pushes it to the OEM side of the world, which deals with the charger as having the intelligence and the ability to interact, which also can push it back into the grid side to deal with the controls and some of the work that's necessary there. So the thing I'll point out today is the old world was pretty much unidimensional. It was very centralized, very older type footprint type thinking and planning. Fast forward to today, integrated, collaborative, working with many partners and stakeholders, and having a say and an ability to contribute in terms of its success. We work better together as teams, and that's what I'm encouraged about with this new group of engineering people, the new group of designers, new group of technology developers. And so some of this stuff exists today, but very rare in a way that is fully bi-directional. And we'll talk about that in a second. So when I look at the V2 vehicle to grid version 2, there is bidirectional capability. It's planned, it's developed, it's able to be deployed, but very few are actually in society today. I will talk about the Ford F-150 is the first. F-150 Lightning is the first fully bidirectional um, model that's coming out. The Nissan Leaf is vehicle to home, not necessarily vehicle to grid. Although when I look at standards coming out, some of the things like Nissan has come up with is the wall box Quasar, which is fully bidirectional, but at the um, at the charger level, not necessarily at the vehicle level. So some of the things that I look at is there is a regulatory challenge. We're still trying to figure out how to incent people to go bi-directional. So most people want to use their cars to drive to get from point A to point B. But if you were guaranteed that you can get from A to B reliably, but also find a way, and I love that polling question at the beginning, it was the third level. People had said, hey, if you provide dollars, I think I will use my car to cash in on those dollars. That is really on the regulatory side to how to treat the incentives so that you're incenting the right behaviors, you're creating a market, you're creating an opportunity. There's still some work to be done there. There are some standards that still have to be developed in terms of bidirectional EV charging with the protocols and how to interface with the vehicles. So a little bit of work to be done there. There are some good work that's been done on global standards. I'll talk about those in a minute as well. And again, the Ford development of the chargers, it's a closed loop system. So Ford in developing their chargers and their bidirectional solutions, it's strictly within the Ford family. Whereas when you look at Europe, Nissan and Schneider and a few of those other people that have developed these products, Schneider has EV Link, Nissan has Wallbox through Quasar. They are trying to make them more open standards. So if I look at the macro level, I'll close out that first half. I think we're in pretty good shape. I think when I look ahead, even though we have a supply at a macro level, supply demand imbalance when it comes to the generation of electrons, so working back into the interconnected parts of the grid, on the supply side, it's tight, but looking out ahead, we have solutions. We believe there's some safe ground ahead. We have clean transport as the next opportunity. Talked about that. We have clean energy supply, connectedness everywhere. Talked about our history of being able to connect everything that needs to be connected. It really is our biggest leverage because we have one of the lowest carbon energy footprints around at a global level. When you look at supply chain, the automakers are filling the pipeline of models and choices, which is more of a human element to go, hey, it used to be one box design. Now you've got many types of things. And there is some effort and work being deployed at the inverter and the logic control side. So more work to be done there, but it's on its way. And again, when I look at planning ahead, I'm encouraged. The forecasts include a netting effect. So this concept that it is bidirectional, it is coming, it is necessary, it is needed, is finding its way into part of our analysis. And last but not least, the regulatory policy, it's under development, but it is in the forming stages. There are studies being done. There is good work that's there that's talking about incenting and managing and playing roles in the sector for all the players that are involved. And one in particular is utilities. When I talk about our particular company, we think we have a big, strong role to play in terms of, and we'll talk about that when we get into the micro side. But really, the issue is a grid integrated player. So on the micro side, this is where I like to play. This is my favorite space. What we're really talking about here is no longer supply and demand, the macro element. We're talking about connection, capacity, investment, communications, data, all the areas that really deal with the one-to-one relationships with the consumer. And that's where the utility LDC plays the strongest part. Knowing the consumers, knowing the behavior, collecting the data, making it available, doing the analytics, being smarter about what we do. One of the studies I picked up from McKinsey talked about the impact. So now we're going from the macro to the micro level. Again, talked about many CEOs talking about billions of dollars in investment to make the grid ready. I think that was a bit of a shock factor. People are looking at that going, hey, we already have an affordability issue with development of the grid. People appreciate low cost energy and really want it. And they believe it's an affordability issue. Well, if you're talking billions of dollar investment, people are going, how can you afford it? And this is where the EVs become kind of the evil side of the equation. They're being used as the villain and going, hey, we need to justify billion-dollar investments because EVs are coming. And some of these studies point to that, going, hey, look at 150 homes, 2 vehicles per home, pretty much North American size footprint. and you look at a 25% adoption rate of EVs in that neighborhood, McKinsey reported out a 30% peak increase in terms of the use of energy. Well, that will create problems for you. Nothing can take a 30% hit when it grows to 25%. 25% is a low adoption rate. So when you look at the impact like that, again, the macro load curve, pretty flat. The micro load curve, when you start dealing at the distribution level, pretty peak. So good opportunity to peak shave, valley fill. But this 30% impact is what people are worried about. And their original reaction is, well, let's just keep increasing the footprint on capacity, build bigger lines, bigger transformers, bigger stations. And the answer to that is not necessarily yes. There is capacity in the system. We just have to be smarter about how we do it. Talk about that in a second. So what we're really talking about is local capacity constraints, whether it's at the service, the transformer, the feeder, the station, in the distribution domain. We're not talking generation. We're not talking transmission. This is all at the local level, and it's understanding it at the micro level. So really, it's connection versus integration, how to effectively manage that. So one of the things that we talked about is regulatory and tariffing structures and incenting behaviors. And one of the other things they found in the study is when they did some throttling of rates, they were able to cut that increase in half by valley filling in the areas where incenting. And what's quite interesting is they talk about the flyback peak in the middle of the night. When they created enough of an incentive and put controls in there, they were able to blunt the effect of the peak, but it also could create a flyback effect in the valley section. And so that is starting to change the load shape curve, but it is still a bit of a peaky type curve. But what's really critical here is customer engagement and predictability. If you're going to go down the road of putting in tariffs and incentives, you've got to really know what motivates customers to do that. Most customers tell you they like a set and forget. And so they want that engagement to be very simple. So that's one of the areas I think we want to be better at it. And again, the local LDC has those preferences and has that data to be able to understand the consumer behaviors. When I look at adding another layer, so just voluntary tariffs, allowing people to opt in and opt out on their tariff structure creates one level of result. Controlling creates an even more effective. So in order to control, we need equipment. So this is where investments start, whether it's signaling equipment when it comes to communications, or software development when it comes to apps and signaling to consumers when to actually to shift and do it, or whether it's including electronics where you can begin to turn things on and turn things off. What we call the smart grid. Utilities have been calling smart grid for a long while. There is even better ability to influence the load shape and do better controls, peaking out so you don't get the flyback effect on the valley fill, and then finding ways to change and alter that shape. So again, I look at this as going, the local distribution companies are key here to be able to install the equipment, the endpoints. It's the endpoint controls, not the macro level controls. And so we need both policy and technology to get even better in that controls world. When I look at standards, really great work here. I did a lot of work internationally with the IEC as SG3 representative of Canada on a bunch of IEC work. And I stole this from work I did back in 2008, 9, and 10, where they were already starting to define the actors and the roles that the actors are playing, and carving out the systems dialogue domains, and then introducing and linking the specific IEC specifications. And the best thing is IEC and IEEE used to go with their own sets of specs, Europe versus North America, and the Pacific Rim were kind of caught in both worlds. They've really consolidated and coordinated those specifications, so they're actually one set of specs, very similar, still under two different umbrellas, but very much coordinated. So very good work done in this domain around defining how the standards work. More work to be done, but we've really defined the domains, the roles, the controls, and those kinds of elements, especially when it comes to communications. So I'm really hopeful. There's some excellent work done there. So one of the things we talk about is signaling our carbon footprint. And The ISO does an excellent job identifying on a daily basis at certain hours of the day what our carbon intensity is from our generation electrical sources. And there are apps that are starting to appear that's begin to signal when's the better time from a carbon footprint perspective to charge or discharge to do a better job around carbon management. So, we were talking about energy management before. There are apps appearing that allow people to adjust their lifestyles and their behaviors and their preferences to fit a better carbon footprint. So, having the characteristics that fit people's needs and doing it through software. So, I was really encouraged by this application I found that really does that. It allows people to set their parameters on a carbon intensity basis and know when to feed in or take out from the grid on that level. So really good work there. More work to be done because there are different preferences, but I'm really encouraged by that. The other thing is around data. So I'm putting up on the screen here. This is a shot of electric vehicles in Oshawa, which is a very dated screen. There is data starting to appear, and I'll give a shout out to my plug and drive people. Kara Kellerman does a great job educating consumers, identifying the need to flag when you buy an EV, to contact your local utility, to share that information. The Ontario government does some sharing around EV. This one screen has us posted at 227. I should have had the other screenshot that we're near 1,000 in Oshawa. So the information has to be timely, accurate, and relevant in order for people to use it. But this whole metadata collection aspect is a trust factor. Most people will not willingly give their information because there's a trust issue. So this is again where the local LDC, been around for 130 years, a trusted delivery agent, a trusted resource. We're not some retailer that's a fly-by-night that just showed up a year ago. We've been around for years. We're a trusted repository of that data. Did a lot of work on smart meters where privacy legislation and those things control what we can and can't do with that data. So we've done a pretty good job setting ourselves up as the agent to collect information, to use that information. Again, that whole data continuum from data to knowledge to do informed investment decision making. Very critical. And last but not least, I come back and go, the utility can play that transactor, a local DSO to be able to transact when, if you're doing bi-directional, when to buy, when to sell, how to incent, how to settle. The ISO cannot do that at a macro level because they do macro market monitoring. They should be able to nest and send signals down to the local regional capacity constraints and have the local DSO manage that so that the end consumer who are participating, it's a distributed resource, who are participating in the models can basically make choices on when to get in and when to get out and how to transact that at a closing market price. And so we're set up to some extent to do some of that with some of the work we already did, the foundational elements around data collection, privacy, smart grid, smart meter. But we got that last step in being able to share this data and knowing where these resources are. And so that requires consumers to share that data with us at that level. So there is more work to be done. At the micro level, we definitely have some more work. I think at the macro level, I can say we're reasonably sound, even though we have that tight supply demand curve. We've done a lot of good foundational work there. That the next major moves are at the micro level. And I was trying to give you a flavor for all the different pieces that have either been developed or need to be developed. But I want to leave you with the last couple of slides where we talk about some of the projects we're working on. So in terms of the work being done, we've been hearing a lot about public transit. I haven't said much about that. So in that public transit domain, mass transit, whether it's GO Train or whether it's busing, Metrolinx or Durham Transit in our particular case, we've got a project we're working on with electrifying public transit with our Durham Regional Transit, our local bus authority, our regional authority, and it's about putting it together an e-bus depot. The neat thing about this particular thing is this pantograph articulating arm to charge 8 electric buses in a new depot they're building in Durham, here in Oshawa, where it's a fast charge, high capacity, articulating arm that basically you drive under, you park it for a period of time, it does a top-up charge to ready to go out, or if it parks for the night, it does a full charge. So that work is being sponsored, and we're doing it in partnership with the Government of Canada, NRCan, ourselves, Durham Regional Transit, and Proterra. The next project is, again, an NRCan funded project that we're involved in, and we're proud to be a lead role player there with the ZVIP funding, level 3 fast charging, battery storage, public EV, and microgrid. And it's at Ontario Tech, and it's working with eCamion, a local battery manufacturing firm here in the GTA, ourselves, and again, NRCan. And it's the level 3 charger. It's a Joule that they've developed, incorporated and involved in a microgrid. Ontario Tech, strong university, strong engineering school, tech with a conscience, has battery, combined heat and power system, district energy, solar panels, and renewable energy, and now battery storage in an EV format, in a public format, to actually go both ways, bi-directional, in their campus format, where we're going to open that up to the public. And we're looking forward to it, to basically explore how we can transact with people who either want to take from the grid or give back in a fast charging environment in a microgrid format. So having those sources come from renewable, having it feed back into the grid, and it's really an interesting project because it involves a lot of partnerships. So we're looking forward to that. It's still in the formative stages, but look forward over the next couple of years. The third area, and we just started this project, we were awarded the Grid Innovation Fund with our partners Peak Power. This one I'm really excited about. Look for this one to be a game changer. It's about using what's in the grid. It's helping us design, or it's helping us use the grid for what it's designed for. And what Peak Power is going to be doing is doing the data analytics piece, being able to squeeze more out of our grid in using the analytics with the data that's available to predict where these EVs are going or where they are in the system, predict where we have the capacity constraints, and find solutions, help us find solutions to use or switch around those constraints so we can use the grid without doing the upgrade. So it's really around making sure that if we're going to do any upgrades, it's using the data wisely to be able to predict out when and where we need it, but where we have ability to supply from the grid, and using that forecasting tools, the analytic tools that Peak Power is developing, to be able to go, yes, we can actually connect X level of EVs in this area. So really encouraged by this. Our partners, it's funded by the ISO. Our partners are Peak Power. And what I like about this one is it's allowing us to make better informed decisions. So again, the analytics piece, using what data we have and knowing what we can predict out about EV and their use and their behavior and where they show up, to be able to go, do we have enough juice in the grid? Can we use the grid more effectively? And if the answer is yes, we will go out and do that. So really encouraged by that one. And the last project, it's still in the development stage, another NRCan innovation application. This one I'm really excited. It's more attuned to vehicle to home charging. It's the wireless charger. So all up to now, I've been talking about these hardwired chargers, standards and connectors. There is another movement afoot in terms of wireless charging. And what I like about this project, it's working with Ontario Tech. My good friend, Dr. Sheldon Williamson, is working with us and NRCan to help put public space ground wireless charging together. And the potential for this and the development of the electronics, it's high efficiency, high output. Up to now, the electronics were low output. They've developed new electronics, power electronics, that can get to the higher charging level. And that allows you to do quick charging. And so if you envision it in a public space, and our thought process is at a stoplight for 2 minutes or 3 minutes, to do a fast transfer of power to top up 10% while you're waiting for the stoplight, this is a game changer. And so we like this particular project. The standards in the OEM world are formulating quite nicely for wireless charging, both the transmitting and the receiving end. And so again, the SAE standards around some of this work is being adopted by some major players. And so another game changer, the next level as it evolves and adapts. And so that project is not funded yet, but we're working on it, and we're looking forward to doing that work with Ontario Tech. I'm going to stop there because I really want to leave times for the Q&A. and I promised him I wouldn't hog the mic too long. So I'm sorry if I rushed through it, but I'm certainly open to all the questions, and I want to leave that time for you guys to go ahead and ask anything.
It's such a big topic. So thank you. You really poured through that at light speed, but good stuff, really good stuff. Okay, I'm going to call on Jason to handle some of these questions that have come in through the Q&A. I will ask the folks who are submitting questions, just keep in mind that we're going to be back next month to continue our conversation about bidirectional. And so we want to leave sort of the aspects dealing with the house end of things, the sort of the consumer facing experience for next month. So the grid and even micro side of the grid is fair game tonight. So Jason, can I get you to come in now?
Thank you, Tim. Okay, so with that said, our very highest voted question is vehicle related, and I know that you mentioned the Ford F-150, so we'll give this one a freebie. The question is, Ford just announced that the package for the F-150 Lightning will cost about $6,000 US. Do you think that cost will discourage use of V2G?
Well, it certainly won't make it encouraging. I mean, a lot of people who are buying EVs are in a certain bracket. And when I look at the consumer data, there are people with a income an income level that has a higher affordability in terms of the type of vehicle they're looking for. So I don't think they'll be happy, but I don't think it'll discourage them. I think people will buy it. And I think Ford's taking a gamble to say, hey, to get bi-directional, which is a need, you're going to have to pay a premium to do that. 6K is it. Let's see what happens. I think it'll be a hot selling item. I think people will want to do that, whether it's vehicle to home or vehicle to grid. I think they see it as a means of cashing out. One of the slides I had before, and what they're working on in the regulatory world, is to make sure that diffuse benefits, who actually pays versus who benefits. They're trying to align policy so that the benefits go to the people who are paying for it. So I think Ford's gambling that, the regulatory folks get it right, that if you want to participate in bi-directional and make a little bit of money, that the 6K investment will have a payback for it.
Thank you. Next one asks, is the EV charging consumption based on theory or actual data? Oh, hold on. Where did it go? Zoom just moved questions around on me. Do the majority of people actually charge their EVs between lunch and 8 p.m.? I typically begin charging my EV after 10, and it takes hours to charge.
This is why I'm really encouraged by the work that Peak Power is doing. I mean, unless as a consumer, you're giving me full control and letting me know where you are, I will know what you're doing and I will know where you're going. A lot of people don't want to do that. So this is where data analytics comes in being able to anonymize where people are going, but be able to see your vehicle footprint, right? So I don't necessarily care who you are. I just want to know why you're there and what you're doing there when it comes to grid connection or interconnectivity. I remember doing work in 2008 for one of the former companies I was with, where it looked at consumer behavior, and it was a Smart Car for Two program. And initially, what was happening was it was interesting to watch consumer behavior with EVs. People who bought the EVs, we were monitoring, and they gave us access to their data. We found that when they first got their EVs and their EV charger, they were charging every day. It took about 3 weeks where they began to charge every second day. And then eventually that waned out over a period of 8 weeks where they were charging once a week. So that whole range anxiety that came out originally, and how they were coining the phrase, people were, were concerned that they wouldn't have enough charge, they'd run out of gas, or they'd be stuck, really didn't materialize. And what we found was consumer behavior shift in how they use EV, especially when they're at the first stage of using it. So this is where I come back to going, the electric utility is probably the most likely candidate to be able to do that. There might be retailers that will be the aggregator of data and be the customer interface, but I don't know that people will trust, a new retailer in that space as much as they would a utility. Now, utilities have to do a better job engaging their consumers. Their old traditional model is, hey, you call us, it's about a bill complaint or an outage complaint, and we have to deal with that. We really have to change our thinking, and we really have to have a better way. And utilities are starting to do that. They have better ways of engaging through different medium and being able to linked to consumer preferences. And we've been doing a lot of work on that in terms of how to get in touch with that customer, not only just from their paying their bill or managing their electron for an outage, but also what are they looking for? Do they need any energy tips? You know, we've been doing a lot of work there. Any help with preparing themselves for an EV? We put out an EV package to all our dealerships to go, hey, if you're considering buying an EV, think about these things before you buy so you can contact us and we can get ready for you. So we're changing the ways we're doing things and growing with that changing consumer behavior and trying to do a better job. And I think utilities are best suited for that. And I think, and again, we need to do a better job, but I think it's about getting into that space to understand that shifting consumer trend with the use of EVs.
Great. This is an interesting one. Do time of day rates still make sense if most of your electricity is derived from hydro? Can you not ramp up and ramp down production within 20 minutes with hydro?
Yeah, well, unfortunately, we have nuclear as our big base here in Ontario, so that's not an easy ramp up and ramp down. It's kind of a flat sort of, square wave. It's either totally on or totally off. But your point is well taken, and that's where I think EVs play in bi-directional. It's a distributed resource. When you put 12, let's say they become all EVs in the province of Ontario, 12 million, 500 kilowatt, 1,000 kilowatt batteries out there that are connected to the grid is a heavy load, but also a heavy resource, a very big resource. And so that's where the controllability comes in. So I like the question. It's not about controlling the big footprint generation. You want to run those things flat out. You want to precision-like control the layer on top, the last bits and pieces to sort of load shape or manage the load shape, or know when to use or draw or put back, and interact at that level. And that distributed resource, a lot of controls have to be put in place. It reminds me of the time of use question. I did some work. Well, we did some work here at Oshawa Power with Sapient around critical peak pricing, and you're hearing that term being used today, where the government is saying, "Hey, we want to introduce more choice and option to consumers. If you want to save energy, we will." The term is used, the elasticity between on peak and off peak. If you make it highly elastic in terms of the ratio has to be 4-to-1. Right now it's 2-to-1. People are getting a little bit antsy at 2-to-1. They say you have to make it much more elastic and make it 4-to-1 to have consumers shift their behavior. Well, the same applies to participate in the grid. If you're getting paid 4 times more for the electrons that you paid 1 time more to get, and you're putting it back into the grid, that's enough of an incentive for people to put it back into the grid at that price point. So I think there's a role for both tariffing, controls in a distributed environment. And again, in that transactive world, I think the LDC plays a strong role there. I don't think the macro market is prepared to deal with that many types of variabilities and trying to deal with it at that level. I think they want an aggregator to bring that to them in an aggregated way.
Okay, here's a out of the box suggestion. What do you think about turning our grid from AC to DC?
Oh, I love that question. If we had to rebuild the grid again, we'd probably do a DC. So I don't think that's a viable thing. Having said that, I remind people, I was around when the last bit of 50 hertz lines went out of service, right? We shifted the grid from 50 hertz to 60 hertz way, way, way back when, but it was all AC. And, and that was a big undertaking, but we did it back then. So I should never say never, right? I don't know. DC is a better way to build that grid for sure. And if you think about all our power electronics, it's all DC. So, can you imagine the shift we'd have to do, either inverters in the home so that you can keep your AC appliances, so you have everything on DC on the grid, and then you have an inverter to move it to AC in the home? It's possible. Maybe. I don't see it in my foreseeable future, but I'm old. I've been around too long. So I'd like to see it. It'd be a huge undertaking. If we were designing it from scratch, DC would be the way to go, is the way I would do it.
That is not the answer I expected, to be honest. Okay.
Well, you again, I remind people, our early studies, when you do electric machines, that AC was rotating machines, right? We needed a rotating magnetic field to drive the industry. And that's where AC came in terms of, yes, you can transmit it over long distances and such, But they've got HVDC now, so that took care of that problem. And in terms of machines, you've got you've got slip rings and DC drives and DC motors. So what the advantage of AC was way back when is no longer the advantage anymore, right?
Okay. Here's a quick one. What was the name of the app that shows the level of carbon generation so a person can choose when to do their charging?
I'll have to get that to you. One of our technical people found that and said this is a neat app. It's a North American app, so he did find it out in the North American websites. But I think the original company came from Europe, so they're marketing it in the States. And again, apps can be downloaded from anywhere. But they saw the need. It evolved out of Europe, where they wanted to get more to they had more of a greener mindset. But it has found its way here in North America. I'll get that and send the note out to whoever wants on that one.
Okay, Tim, time check. Can I squeeze in a few more?
Yeah, I think we're good to go. It's 8:22. We can go for another 5.
Okay, great. Next one is, I love the sound of wireless charging, allowing infinite range. I read very recently that the efficiency of wireless could be better than wired. Is that seriously possible?
Well, in the one slide I showed there, it's almost on a par level. So, at one point, the whole issue, what's driving that is gallium nitride electronics, right? They're moving out of silicon into gallium nitride, which has got great thermal dynamics and power transfer capabilities. So in building those electrons with those tools, they're able to deal with the thermal problem in pushing electrons and squeezing it through in a short period of time. So the efficiency is up, the power transfer is up, the thermal impact on the electronics is down because it's able to handle it, and therefore the charge time is reduced. So I think that is the next game changer. If you can embed these, in places where you're stopping for 3 minutes, you can get a 10% charge, and that's all you need when you're running around town, 10% at a time.
Okay. When do you think that third parties will be allowed to charge for charging by the kilowatt hour rather than time?
Well, so that's a great question because we've introduced our on-street charging. We just did some in Oshawa level 2 chargers, and we've allowed them to charge free for now for the time being. It's not necessarily the price of the electron. It's always been a pain for people getting into the charging game, whether it's ChargePoint or IV or all these things. People are charging. They charge a convenience factor. They charge a parking rate, which includes the electron and the cost of the charger. I don't think anyone's figured it out how to make money with these things. I think people are trying to get to a size and footprint to a level, and that's why governments continue to incent some of these things to get them deployed out there. Is they're not money makers for sure. If you try to make them money makers, people will charge disgruntledly. They'd pay the $20 convenience fee, but they really feel like it should not be that high. Certainly at gas at almost $2 a liter, you'd think, hey, 20 bucks compared to $100 fill-up or $200 fill-up would be a better place to go. But I still think the consumer reaction is a little bit disgruntled when they'd have to pay a convenience fee. What I think work in that space for utilities is go, listen, just use the fob on your car, unplug the wand, plug it in, put it on your hydro bill. Whether you're coming from outside Oshawa here, I'll work with your local utility, send that bill over there. It'll show up on your regular utility bill, and you get a statement for everything you're using in electrons, whether it's local or whether it's abroad, for your EV or for your home. I kind of like that model. We have that transactability at the retail level because we had energy retailers out there. So those tools are built. How do we use it in such a way that we could now connect them to the wand rather than the meter in a different district? And I think there's potential there, but utilities have to work together. If it were me as a consumer, I just like one statement for all my electrons, whether I get them at home or abroad. I don't want to have to deal with a credit card here and a subscription here and something else somewhere else. So I think there's plenty of room for further development there, and hopefully we get it right.
Great, thank you. One more, Tim, please.
Yeah, one quickie.
One quickie. This is one that I think we want to repeat next month as well, because I want to see Mabel's point of view on this. When do you think that we'll reach the point where solar, passive design, battery storage, and vehicle to home will make it such that individual homes will not need to even be connected to the grid?
Well, bite your tongue on that one. So, that puts us out of business. No, I think there's always a grid management function because, again, energy is everywhere in the province. I mean, we did a great job connecting everybody. I love the question. It reminds me of a project we did with Neto of Japan and Tabuchi. It's a solar energy management storage system, SEMS. We did 30 homes in Oshawa, solar 10 kilowatt battery in the home. And we had 2 people who signed up for that program that had a Nissan Leaf that wanted to integrate that. And we did. We successfully integrated the Leaf at that time. So this is going back about 5 years, where they wanted to be able to move the electrons rather than offset behind the meter or put it back into the grid. They wanted to put it into their vehicle. So they were able to control that charge in a way that they were able to fill it with whatever electron. And this one person was so well tuned in it. I mean, he was almost fanatical, but it was great to see. He was on top of the hourly price, the HOEP, and he was going, no, it's better to charge my car for this, or it's better to put it back into the grid, or it's better to offset my load in the home. So it's doable. My fast answer is it's very doable. There is technology out there today. It's a question of how much effort do you want to play in doing that. I think most consumers want it simple. I'm a set and forget guy. If I give you my lifestyle, my vision of the electricity industry is if I give you my lifestyle in a program, you'll take that program and manage it in such a way that I don't have to worry about managing it. It's done for me. So, I have to program my lifestyle to you, and then you'll manage it in a way that meets my desire. That's my vision of the future. And I think that fits in that question.
Well, I hope that version of the future comes to play. I hope it does. Jason, thanks so much for walking us through the questions. And Ivano, awesome information. I mean, somebody with your background and experience I'm sure you could talk all night about this subject, and you'd be happy to do it. I can tell.
It's my pleasure.
Yeah, no, it's really great. I appreciate it so much. And so I have to say that next month by the way, poor old Tesla, I think he's rolling over in his grave after the AC/DC thing. Oh my goodness.
Oh yes, absolutely.
Yeah. So next month we're going to continue this discussion about bidirectional with an emphasis more on the sort of the consumer side of it. What preparations and what options will we face as we prepare our homes for this new capability? And to address this subject, as Jason led into, we're going to welcome Mabel Fulford, who's Director Innovation Execution at Peak Power. And Ivano was good enough to give Peak a little plug there, no pun intended. Peak Power is a Canadian climate tech company at the forefront of energy transition that believes battery energy storage has the potential to fundamentally disrupt the energy sector. And Peak Power is currently running a pilot V2H, vehicle to home program with Hydro One, using a fleet of Nissan Leafs to understand better how consumers might use and benefit from this new ability, just as Ivano was describing. So everybody, please mark the date. There's a lot more we can cover on this topic, but we do thank Ivano for the great start. And we thank you all for joining us on today's episode. And from all of us at Electric Vehicle Society, and until next month, we hope you all stay well. This concludes today's webinar.